The lesson method of connection the electric resistors. Question. What are method of connection the resistors? Answer. Number 1, connection in series. Number 2, connection in parallel. Connection in series. This diagram, the electric circuit are connected in the series. R1, R2, and R3. This battery, positive pole and the negative pole, this electric cable. When close the electric cable, the electric current flow in this circuit. The direction of the electric current from positive pole to the negative pole. This electric current is called conventional current. Now, I total equal I1 equal I2 equal I3 because found one path to the electric current flow in this circuit. V total, the total electric potential difference. Potential difference of the battery represent the total electric potential difference in the electric circuit. V total equal V1 plus V2 plus V3. This equation 1 and this 2. But V equal R times I. Substitute this equation in the equation 2. V total R equal times I total. V1 R1 times I1. V2 R2 times I2 plus R3 times I3. R equal I total equal I R1 plus R2 plus R3. The electric current is equal. Divide two sides of equation on the I. Cancel I with I. R equivalent equal R1 plus R2 plus R3. This equation 3. This equation using to find or to calculate the equivalent resistance. Example. The two resistance 4 ohm and 8 ohm are connected in series with each other. Then they are connected to the source voltage, 24 volt. Calculate number 1. The equivalent resistance. 2. Potential difference of each resistance. Information given. R1 equal 4 ohm and R2 equal 8 ohm. V total equal 24 volt. The potential difference of the source voltage or of the battery represent the total potential difference. R equal R1 plus R2 plus or equal 4 plus 8 equal 12 ohm. This equivalent resistance of the electric circuit. 2. Potential difference of each resistance. To calculate or to find potential difference need amount of electric resistance and the amount of the electric current. In the beginning, I total equal V total divided by R equal V total 24, R equal 12, equal 2 ampere. I total equal I1, I2, I3. I total equal I1 equal I2 equal 2 ampere, because the connection in series. Now, V1 equal R1 times I1. R1 4 multiply 2 equal 8 volts. V2 R2 plus or multiply I2. 8 times 2 equal 16 volt. 8 plus 16 equal 24. The 24 is the V total. Problem of chapter 3 in page 52. Problem 3. The two resistors R and 2 ohm are connected in series with each other. Then, we're connected in the two ends of the source, electric potential difference equal 12 volt. Electric current flow in the circuit equal 2 ampere. Calculate number 1, the unknown resistance. Number 2, the potential difference of each resistance. R1 unknown, R2 equal 2 ohm, V total equal 12 volt. The potential difference of the electric battery equal or represent the total potential difference. I total equal 2 ampere. Solution. In the beginning, R equal V total divided by I total. R equal the equivalent resistance equal 12 divided by 2 equal 6 ohm. R equal R1 plus R2 because the connection in series. R equal 6 ohm. R1 unknown. R2 equal 2 ohm. R1 equal 6 minus 2. R1 equal 4 ohm. This amount of unknown resistance. Number 2. Calculate the potential difference of each resistance. We need electric current and the amount of the first resistance and the second resistance. I total equal I1 equal I2 equal 2 ampere because the connection in series. V1 represents the potential difference of the first resistance equal R1 times I1. R1 4, I1 2 equal 8 volt. V2 represents the potential difference of the second resistance equal R2 times I2. 2 multiply 2 equal 4 volts. When plus 8 volt with 4 volt equal 12 volt. 12 volt equal the total potential difference. Question. Three resistors R1, R2, and R3 are connected in series with each other and are connected with the two ends of the source voltage, 60 volt, and the electric current is 3 ampere. Calculate. Number 1, the unknown resistance. 2, potential difference of each resistance. This diagram of the electric circuit. This R1 is unknown, R2 equal 5 ohm, and R3 equal 12 ohm. 12 ohm. The potential difference of the battery equals 60 volt, and the electric current flow in the circuit equal 3 ampere. Information given. R1 unknown, R2 5 ohm, R3 12 ohm. V total 60 volt, and I total 3 ampere. Number 1. R equal V total divided by I total. V total equal 60 and I total equal 3 equal 20 ohm. R equal R1 plus R2 plus R3. R equal is the equivalent resistance equal 20 ohm. R1 unknown, R2 5 and R3 equal 12. 20 equal R1. 5 plus 12 equal 17. R1 equal 20 minus 17. R1 equal 3 ohm. This amount or magnitude of the unknown resistance. 2. Potential difference of each resistance. If calculate the potential difference of each resistance, we need electric current and the amount of the electric resistance. I total equal I1, I2 equal I3 equal 3 ampere, because the connection and series. V1 equal R1 times I1, R1 3 times I1 3 equal 9 volt. V2 equal R2 times I2, R2 5 times 3 equal 15 volt. V3 R3 times I3, 12 times 3 equal 36 volt. 9 plus 15 equal 14, or 24. 24 plus 36 equal 60. This potential difference electric. Now, activity. Connection electric lamp in series. Tools. Small and identical lamps, a proper voltage battery, wire, and cable. Steps. Number 1. Connected one of the 3 lamps with the battery and electric cable. When close the electric cable. the electric current flow in the circuit, we observe the lamp is glow. 2. Now, connected to lamp with the battery on. Okay. 1. Close the electric. Okay. The electric current flow in this circuit, and observe the lamp is glow. Are equal but less than the first case. 3. Connected 3 lamp with the battery, this positive pole and negative, and close the electric the electric current flow in the circuit. We observe the 3 lamps are equal glow, but less than the previous state. From this activity, conclude when increase the lamp in the electric circuit, decrease the electric current, because increase the electric resistance of the circuit. We conclude from this activity, when increase the lamp in the circuit, decrease the electric current, because increase the electric resistance of the circuit.